Hello, everyone, wherever you are in the world. I hope you are staying healthy and safe. My name is Olga Hakava. I'm an Associate Director at the Atlantic Council Global Energy Center. This week, I am stepping in for our Director, Randy Bell, who is taking a well-deserved and overdue staycation. Randy, I hope you're enjoying a nice cold beer right now. Thank you all for joining us for EnergySource Innovation Stream, where we aim to highlight new energy technologies with the potential to reshape the global energy system through discussions with companies and individuals working diligently to bring those innovations at market scale. Today, we'll hear from Mr. Oliver Cameron, a co-founder and CEO of Voyage, for a discussion about the company's development and deployment of autonomous vehicle technologies. But before we get started, I have two small reminders. First, please follow us on Twitter at AC Global Energy and use the hashtag InnovationStream. Second, after Oliver's presentation, you can submit your questions through the Q&A function in Zoom, and I will make sure to get to as many of those questions as possible. If you're watching from other platforms such as YouTube or Facebook, unfortunately, we will not be taking questions through those platforms. So it is my pleasure to welcome Oliver Cameron to Atlantic Council. Oliver, thank you so much for being here with us today. How are you doing? I know that you're based in California. How are things there? How are you holding up?
Firstly, thank you for having me. All things considered, doing okay. California, or rather the Bay Area, has handled a lot of this craziness quite well. So, all things considered, doing okay.
Well, really glad to hear that you're doing well. Well, if you can share your screen, we can go ahead and get started.
Definitely. Let's do it. Okay. Okay. Screen successfully shared, I think. Yes, perfect. Okay, let's begin. So, we're Voyage, and we're launching a fully autonomous ride-hailing network in months, not years, and we've accomplished this with millions, not billions. Our state-of-the-art driverless technology is ready to commercialize in a very defensible $800 billion market, serving customers who we know will be the power users of self-driving cars. We have deals signed with top-tier automakers, fleet maintainers, insurers, energy providers, and 10 US communities, complete with region exclusivity. These partnerships enable a very rapid and capital efficient go to market. We've built one of the very best teams in this industry, hiring from companies like Tesla, Cruise, Apple SPG, Google, and more. As a quick introduction to myself, I was very fortunate to have the opportunity to work closely with one of the pioneers in self-driving cars, Sebastian Thrun, who founded the Google self-driving car project. With Sebastian, I led Udacity's deep learning, robotics, and self-driving car curriculum, teaching these technologies to millions of students all around the world. And at Udacity, I also served as the VP of Engineering, Product, and Content. I am extremely fortunate and lucky to get to work with some amazing folks at Voyage, including Nina and Davide, all of whom have tremendous experience in the self-driving industry and a burning passion to bring this technology to market ASAP. So there's always been a tremendous amount of debate about when self-driving cars will finally arrive. When is the future finally coming? And the truth is that self-driving technology remains years away from being safe and scalable in dense urban environments. The complexities of these environments, paired with the limitations of today's machine learning and robotics, means we are quite some time from robotaxis being a part of our daily lives, specifically in cities. Now, what we've always known at Voyage is that asking when self-driving cars will arrive is the wrong question. It is all about where self-driving cars will arrive and where it can add value today, because the state of the art in self-driving technology is ready to commercialize in karma communities right now. So, like Amazon with Amazon Books, our strategy is to start simple and expand rapidly instead of trying to solve the world from day one. And this approach really does have three key advantages. Number one, we will be the first to market in hundreds of regions across the country, meaning we will have a many-year head start to refine our product, commercial playbook, and unit economics. Number two, we don't require billions in capital to simply deliver a product in the first place, given the simplified technical requirements and the desperate need for improved transportation within our target communities. And then number three, we signed region exclusive commercial agreements with our partner communities, allowing us to deeply invest in those regions without detrimental competition and pricing pressures. To give you a sense of the scale of some of our communities, in one particular community, we have 5 years of region exclusivity with a 125,000 resident community in Central Florida. Okay, so just like millennials were the power users of social media, our belief is that senior citizens will be the power users of driverless technology. Self-driving cars will enable many, many millions of seniors to regain the freedom and independence that they lost when they stopped being able to drive. And the data also really backs this up. Seniors today pay a substantially higher cost per mile to drive their own vehicles than non-seniors, a problem that the cost efficiencies of self-driving will solve. 17% of seniors don't have a driver's license today, and that stat very much surprised me. And seniors on average outlive their ability to drive by about 7 to 10 years. Also, seniors suffer with more disabilities than non-seniors, making driving your own car incredibly challenging. It's also important to note that seniors move a lot. In the US, every day, 5 billion trips are taken by seniors, which I'm sure we can all agree is a lot of trips. Okay, so in just over 3 years, with tens of millions of dollars spent, we have de-risked much of what has made self-driving a historically risky bet. We have locked up 10 of the very best communities for our approach with region-exclusive agreements. We have signed partnerships with top-tier automakers like FCA, fleet maintainers like Enterprise, insurers like Intact, and energy providers like Chevron. And finally, thanks to the rapid maturation of our technology and the key partnerships we've signed and the simpler, calmer roadway in our communities, we are on the cusp of deploying revenue-generating driverless cars years before most anyone else. Again, this will enable us to get to market ASAP and refine our business before others can do so. What you see in these videos is our self-driving cars autonomously driving within our target communities. You can see that although there is a simpler roadway here, there is still a hell of a lot of complexities that we've had to overcome. And it's been super exhilarating to see our team tackle these challenges and bring this whole thing to life. Okay, so we believe in working with our communities and not against them. And by working with them, the reward is region exclusivity. We get to be the only self-driving provider in the region. And then to monetize, we go directly to their residents to monetize with our autonomous ride-hailing product. Think Uber, but with self-driving cars. Now, we provide these communities with obvious monetary value and utility, but we also give them skin in the game with a small equity grant. And what we found is that this really aligns all incentives. It means that if we win, our communities win, and we know that if we do win, it's in large part thanks to those communities. And what we've learned is that real estate developers, many of whom we are partnered with, operate just like any other company. You know, they're always looking for ways to acquire new customers, lower their costs, increase their product value, and a ubiquitous autonomous ride-hailing service deployed within their community, which promises to reduce fatalities, offer cheaper trips, and really enable anyone, whether they can drive or not, to move, is a very powerful pitch that we've seen a lot of success with. Okay, so the Villages in San Jose, which is one of our partner communities that we've been working with now for just over 3 years, will be the first community in the world where you will be able to travel from any other address to any other address in a fully driverless vehicle. And I can't undersell how awesome and how powerful that will be if you're a resident in that community. It will mean you'll be able to take a trip to the park, visit a friend for lunch, go for dinner, visit the stables, head to the gym, or to one of the many community centers there, and to not have to worry, can I drive my car, or is the time of day not compatible with my vision, or things like that. And this community is very special, full of residents who are extremely passionate about democratizing access to safe transportation. We love working with them, and I actually believe a few of them are on this call. So a hello to all these residents, and a thank you for letting us partner with your community. Okay, so for the last 3.5 years, we've been focused on delivering a set of driverless technologies to enable our vehicles to safely navigate calmer commuters point to point at 25 miles an hour. This isn't a 10-mile-an-hour shuttle that stays on a fixed route. This is a autonomous ride-hailing service where you can move from any address to any other address within the bounds of your community. And what's more, this technology is very extensible, capable of evolving to more complex communities in the future. There's 4 key components that make up our technology: Commander, Shield, TeleAssist, and the G3. I'll talk through Commander, Shield, and TeleAssist, and the G3 is our vehicle that we are partnered with Fiat Chrysler on that is ready for truly driverless operations. Okay, let's start with Commander. Commander is the brain of our driverless technology, responsible for perceiving the world and making safe, intelligent decisions. To deliver a driverless car today, and not just a research project, we blended the best of classical robotics with the state-of-the-art in machine learning. And this approach means we can take advantage of the cutting-edge nature of machine learning today while compensating for its weaknesses with tried and tested classical approaches. What you can see in this video is Commander perceiving the world around it every 100 milliseconds, predicting what those objects will do next, and then executing the safest possible decision. And what's really extraordinary about Commander versus a human, even though humans are relatively good drivers, all things considered, is that Commander can track objects like pedestrians, vehicles, or really any mass up to 200 meters and in 360 degrees. Imagine if you had eyes in the back of your head, and those eyes also shot lasers out of them to measure the precise distance of objects relative to yourself. That's what Commander can do. Shield is another important piece of our technology. It's an intelligent automatic emergency braking system designed from the ground up for a self-driving car. If Shield detects that for any reason, hardware error, software error, that we're about to experience a safety critical issue, Shield hits the brakes and brings the vehicle to a safe state. TeleAssist, simply put, TeleAssist ensures the customer always gets to their destination. Even in calmer communities, the unexpected can happen and does and will happen, albeit less than in cities. And while Commander can autonomously handle many of these situations, it can find itself sometimes confused and stuck. Self-driving cars today don't really have human-level general intelligence. So to solve this, TeleAssist presents multiple options to a human who is sat far away from the vehicle in a remote call center, if you will, who makes the call on what the vehicle should do next. However, and actually this is the first time we've talked about this publicly, so that's pretty neat, but we've also taken teleoperations a step further than what we've seen from other autonomous vehicle companies. And we built something that we're very proud of that we call the remote pod, which is what you see in these images right here. The remote pod is a proprietary and automotive-grade workstation for our teleoperators to safely remotely drive the car at low speed. Sometimes, as we all know, a situation on the road is not binary, and a decision is simply not enough. Sometimes a human just needs to take the wheel and drive the car through an unexpected situation. Think about confusing construction, needing to pull over to the left for emergency vehicles when there's nowhere to go on the right, vehicles boxing you in, crazy parking lots, and lots more. TeleAssist, the remote pod, and all the algorithms under the surface to enable all this to operate safely enable us to deliver a comprehensive ride-hailing service that always gets a customer to their destination. So simply put, we offer a door-to-door autonomous ride-hailing service directly to the residents of our communities. It's a very simple product. works much like the ride sharing services that we're all used to today. But of course, it has a lot of complex technology and operations under the hood. And if there are any community leaders listening out there, we are expanding today to new regions and would love to talk to you if you believe your community would embrace a autonomous ride hailing service. So to conclude, our industry has a long way to go, but what is happening at Voyage and other self-driving companies is going to usher in a new type of vehicle. This vehicle is going to be safer, it's going to be cheaper, it's going to be less damaging to our planet, and above all, accessible by everyone. I think we can all agree that that is a good thing. So we are working very hard to bring this vision to life, focus initially on delivering it to customers who desperately need something better than they have today. And although there's been bumps in the road in the self-driving car industry, we can see a very clear path to accomplishing this sooner than many think. And frankly speaking, we couldn't be more energized to work on this problem every single day. And to finish, I just like to read a few quotes from some seniors, if that's okay, reading from my phone here. So 3 quotes. My husband, due to a head injury and reduced vision, cannot drive. So I have to drive him everywhere. A self-driving car would probably mean the biggest improvement in our quality of life that I can think of. Number 2, a self-driving car would solve the high premiums on my insurance. My wife and I have had multiple accidents, and the insurance is about as high as my house payment. Number 3, I am elderly and do not have a car, so I have to rely on family and friends. I could go to the doctors, shopping to get groceries or meds, and never have to bother anyone again. I like to go to thrift stores, and no one likes to take me. Wow, I could go wherever I want. And this is Jerry, one of our many happy customers. And now I'd love to answer any questions that may be on folks' minds.
Thank you so much, Oliver. This was fantastic. As a reminder, please put your questions into the Q&A function on the very bottom of your screen. If you just click on that and type in your questions, I'll make sure to read it out to Oliver. I'll go ahead with the questions, Oliver. We know the transportation sector accounts for a significant portion of greenhouse gas emissions. And I know you touched a little bit about the environmental benefits that this technology can bring. But can you talk more about the efficiencies that we can see from this technologies? I know that even just slowing down and accelerating through this technology can save tremendous amounts in fuel costs and such. But what are some other efficiencies that are happening now, and what are some potentials for future efficiencies that could cut down greenhouse gas emissions, but also other pollutants?
Yes. So as you said, it's important to break down the fleet improvements and then the vehicle improvements, right? So on the vehicle side, we're going to, with our 4th generation vehicle, transition to a fully electric vehicle. And this is the vehicle that we're going to be scaling, in the thousands. And it's obviously beneficial for that vehicle to be fully electric, and that's happening. And then also on the vehicle level, like you said, there's a lot of efficiencies that a robot driver can really bring. That robot driver can brake according to energy efficiency, can accelerate, can take the most optimal path, the most optimal elevation, all these kind of micro optimizations to make sure that that trip uses the least amount of energy possible. And you know what? That's incentivized, or the incentives of that are aligned with ourselves, because not only do we want to, of course, reduce the pollution in the planet, but by being optimal with our energy usage, we also reduce our costs, which is, of course, important to make this sustainable. And then you've got the, let's say, fleet benefits. And at the fleet level, there are some incredible optimizations you can make. Firstly, you can make sure that you have just enough vehicles on the road at any point in time. You can really minimize the waste of having too many vehicles, too much downtime, as it were, of vehicles that are just driving around. And then secondly, there's interesting work that I would say is still a little bit futuristic on how vehicles can best interact with each other. So, you can firstly make sure that vehicles, like we talked about, are braking and accelerating efficiently, but also think about how these vehicles can interact with each other. They can get very close with each other because they know that that is safe when you've got all these crazy sensors on the vehicle. So anyway, lots of ideas. The truth is, though, this has not yet, of course, been proven, but I feel very confident that there's a huge amount of kind of micro and macro optimizations to make.
Thank you for answering that. We have several questions on the teleassist, teledriver, and the operations there. One of the participants is wondering how many different cars can the teledriver operate at the same time? And then also we have a question on the, any legal implications or any legal details that need to be thought of as people are using teledriver to be able to take over the car. Are there any legal implications there?
Good question. So to start with the ratio, we're not yet announcing the ratio just publicly. It is important to think of this as a technology that's there when to get the customer to the end of their trip. So if that was the bulk of the trip that Teleassist was driving, that from a unit economics perspective doesn't really work. So we're definitely focused on making Commander, the intelligent autonomous brain part of the equation, drive 99% of the trip. And then Teleassist is really there for that edge case, that time when crazy construction presents itself, when there's a whole bunch of emergency vehicles behind you, and you just need to drive with human intelligence for 5-10 seconds at 5 miles an hour just to get out of the way or just to navigate that situation. So you can definitely think of it as a ratio 1 to X, in the sense that one human is going to be monitoring a number of different vehicles. Then on the legal implications, so another reason that we believe we can bring this to market sooner is that we've partnered with some great companies to really figure out these problems. So one of those companies is Intact, from a insurance perspective, who's looking to really innovate when it comes to autonomous vehicle insurance. And we've partnered with them to bring the full suite of our technology to life and make sure that it is insured way above and beyond reasonable levels. The other thing that I would make mention about Teleassist is that we have thought really deeply about how to make this safe, because if there's been a few companies over the years that have tried to build remote driving at high speeds. We don't believe this is possible safely, just given latency, the networks, all that sort of stuff. So we've spent a tremendous amount of time firstly making sure that the hardware is at the sort of safety levels it needs to be, and the remote pod, like I mentioned, is automotive grade. That means the steering wheel is automotive grade, the pedals, every connector, the pieces of compute in that pod, all automotive grade. The second thing is that it's at low speed. So think about 5 miles an hour max. And then the third thing is that there's a whole abundance of computer vision algorithms that make sure that the remote operator, given the latency challenges, can't do something dangerous. So we've got redundant perception algorithms, computer vision algorithms that ensure that that remote operator cannot drive into an object, for example. Thus, again, fulfilling its purpose of just adding human intelligence to the drive.
Wonderful. We have a question from Lawrence Williams, who is wondering, is there going to be ever a time where you don't need the teleassist, where the cars can do this on their own? You touched a little bit on the safety component and the importance of teleassist, but could you talk about the long-term future? Will we always need to have something kind of in the back end getting ready to jump in case there's a situation?
It's definitely going to be a decreasing reliance over time in terms of the remote driving piece. Again, we hear from hundreds of seniors around the country who physically cannot drive and need a service like ours. So we feel that urgency to get to market, and Teleassist and the remote pod are a big part of how we can do that so fast. But that said, as we start to experience more of these edge cases and refine our software, again, the need for remotely driving and humans helping the vehicle is going to decrease over time. Today, again, 99% plus of our driving is fully autonomous, but those edge cases do present themselves. So it's going to be a decreasing reliance. That said, I'd also note that it will be, I doubt there is a future that is, not too distant from now where a fully autonomous car can operate without the need for a human behind the scenes. And again, this will be a ratio. This won't be a one-to-one connection. This will be a one-to-many. But there will be times where a human has to help the vehicle. And I see that, I won't give a date or a time range, but I see that being the need for some time.
Great. We have a question from Lily Liu, and this pertains to, you mentioned all the safety precautions that are in place, but when it comes to programming, is there ever a time where the car needs to choose between passenger and pedestrian priorities and safety? Does it ever come down to it, or what are some things in place that kind of address that ethics question?
Yeah, this is the age-old trolley problem. And, a lot of people in self-driving, myself included, struggle with this question because, if I look back at my driving record now over the course of, 13, 14 years, I've never encountered a situation where I've had to myself intuitively choose between, running over a grandma or avoiding the baby in the stroller. It rarely happens in that sort of manner. That said, it is really important to note that self-driving cars are, contrary again to what some in the industry might think, they're not a human intelligence, right? They don't have the brain that we have. They don't have the years of evolution and the many other things that make a human human. So the types of decisions it's making are a little more boring, I would say, than choosing between those things. The other thing I'd like to note is that the danger and the ethics questions are really revolve around speed. And one of the things that we've been very insistent on is that if you're going to bring autonomous ride hailing to market now, it cannot be at 50, 60, 70 miles an hour. There's a lot of unknowns, a lot of risks of that. So we focused intentionally on 25 miles an hour and below because we think that's the safest way to deliver this technology and expand over time to different speed limits and faster speed limits. But let's firstly get the 25 mile an hour and below version out where we perhaps don't have those sorts of same ethics questions that a 70 mile an hour vehicle may have.
Wonderful. I have a question regarding cybersecurity measures that you're taking to make sure. I know you touched on this a little bit in your presentation, but could you talk more about, what are the risks, how are you mitigating them?
Yeah, so anything that can be programmed to do something is a exposed risk, right? And you have to be conscious of that when you're designing these vehicles. So first and foremost, one thing that's really important to note is that when it comes to the vehicle itself, that's probably the most important piece of the equation. Your vehicle has to be ready for truly driverless operations. And through a partnership that we have with Fiat Chrysler that we recently announced, we have access to a vehicle that is quote unquote driverless ready, meaning the interfaces to the car are hardened, meaning hardware redundancies in braking and steering, and a few other bits and pieces. The other thing, though, around what we control is you've got to not be cavalier about this. We're not building a enterprise SaaS business. There are real risks with our technology, and there's real risks of a 3-ton vehicle doing something dangerous. And your culture has to really live and breathe that every single day. And I believe passionately that we do that every day. And that means that we pay attention to this. That means that when we talk about teleassist, all of that traffic is encrypted, all of that traffic is hardened, locked down, and we don't see viable paths for issues today with that.
Excellent. One final question, if you can give a 20-second answer, that would be fantastic.
Sure.
This is coming from a grad student in robotics, Wamshi, and the student is asking, are there any scenarios where the vehicle gets confused still?
Oh, yes, many. So again, the state of the art in driverless technology is not human level. I'll try and be very succinct in this, but there's cases where you have uncertainty and we wouldn't perceive it as uncertainty, but a robot does. And for example, an overtake. Whenever you're entering the oncoming lane of traffic to overtake a vehicle, you're adding additional uncertainty. And for the robot to gain the certainty it needs can be quite a challenging process. So you can think about it from that perspective instead of specific examples.
Well, thank you so much, Oliver, and thank you everyone for tuning in, and especially for your excellent presentation. Make sure to connect with Oliver on LinkedIn and follow him on Twitter at Oliver Cameron. And you can also follow the company at Voyage. Stay up to date with recent developments, and make sure to follow Global Energy Center and Atlantic Council. This presentation will be available on the Atlantic Council website, YouTube, Facebook, and Twitter. I would like to extend thanks to Laura, Roger, Jasper, and Katie for your hard work in making today's event happen. I hope you will join us for the next production of Innovation Stream on July 10th with experts from Siemens and Spark Cognition, who will discuss AI-driven cyber defense system for distributed energy assets. Thank you all for tuning in. I wish everyone a safe and relaxing 4th of July weekend. We hope to see you next time at EnergySource Innovation Stream.
Awesome. Thank you.